stunning fossil discovery. Mirasaura Grauvogeli challenges pre-dinosaur evolution. Imagine a world where our understanding of pre-dinosaur evolution is turned upside down by a single, extraordinary fossil discovery. Welcome to the astonishing story of Mirasaura Grauvogeli, a tiny, tree-dwelling reptile from the Triassic period that has left scientists stunned and flabbergasted. This remarkable creature, which lived over 247 million years ago, has challenged everything we thought we knew about the evolution of life on Earth. But here's where it gets really interesting. Mirasaura Grauvogeli possessed unusual structures that resembled feathers, yet were entirely distinct from those of birds or dinosaurs. In fact, these feathers date back more than 100 million years before the first flying dinosaurs, forcing us to rethink our assumptions about the origins of flight. The discovery of this tiny reptile, which was just 6 inches long, has sent shockwaves through the paleontological community. With its curious combination of features, including clutching feet like a monkey, a narrow bird-like skull, a prehensile tail, and a row of faux feathers along its back, Mirasaura Grauvogeli is a true marvel of nature. But what's even more remarkable is that this creature likely perched in treetops, using its unique features to navigate its environment. The discovery of Mirasaura Grauvogeli also resolves a decades-old mystery surrounding a Soviet-era fossil and has sparked a new wave of interest in the evolution of reptiles. So, what can we learn from this incredible discovery? For starters, it highlights the complexity and diversity of life on Earth and challenges our simplistic notions of evolution. As paleontologist Steve Bersati notes, "It's been a long time since I've been so blown away by a new fossil discovery." But here's the thing. This discovery isn't just about Mirasaura Grauvogeli. It's about the broader implications for our understanding of evolution. As co-author Stefan Speakman points out, there was always a distinction made between feathered dinosaurs and scaly reptiles, and that's too black and white of a story. So, what's the real story? It turns out that feathers and fur are complex structures with diverse functions and are not exclusive to bird and mammal lineages. In fact, integumentary appendages, structures that grow from the skin, may have been far more common in ancient times than we previously thought. The discovery of Mirasaura Grauvogeli has also shed new light on the evolution of trypanosaurs, a group of tree-dwelling reptiles that are still not well understood. As Speakman notes, to me, the closest analog is a pygmy anteater. But what about the controversy surrounding Longisquama, a strange reptile with feather-like structures that was discovered in Kyrgyzstan in 1970? Does the discovery of Mirasaura Grauvogeli offer new context for understanding this enigmatic creature? It seems that Longisquama may also be a type of trypanosaur, which would challenge our current understanding of its place in the evolutionary tree. So, what does it all mean? The discovery of Mirasaura Grauvogeli is a powerful reminder that evolution is a complex and multifaceted process, full of surprises and contradictions. As Bersati notes, what we have here is a remarkable example of convergent evolution, maybe the most stunning one I've ever seen. But here's the question. What do you think? Do you agree that Mirasaura Grauvogeli is a game-changer for our understanding of evolution? Or do you have a different perspective on this incredible discovery? Let us know in the comments. And this is the part most people miss. The discovery of Mirasaura Grauvogeli is not just about the past. It's about the future of evolutionary science. As we continue to uncover new fossils and shed new light on the history of life on Earth, we may be forced to rethink our assumptions about the very nature of evolution itself. So stay tuned. The story of Mirasaura Grauvogeli is just the beginning. Shocking discovery. Feather-like appendages in Triassic reptile. A revolutionary discovery in feather evolution. The crested diapsid reptile from the Middle Triassic. Paleontologists have unveiled a groundbreaking new genus and species of Triassic trypanosauromorph diapsid, characterized by remarkable integumentary appendages that are neither feathers nor skin. This discovery, based on 2 exceptionally preserved skeletons along with additional specimens, challenges the long-held belief that feathers and hair-like structures are exclusive to birds and mammals. Imagine the scene. Mirasaura Grauvogeli, a unique creature prowling through its lush forested habitat around 247 million years ago, hunting for insects. Image credit, Gabriel Ugueto. Feathers and hair are intricate appendages found on the exterior of vertebrate animals, serving vital roles such as insulation, sensory enhancement, visual displays, and even aiding in flight. While feathers trace their lineage back to the ancestors of birds and hair to those of mammals. The genetic framework responsible for these appendages likely has much older origins within the amniotes, a diverse group that includes reptiles, birds, and mammals. Dr. Stefan Speakman from the Staatliches Museum für Naturkunde Stuttgart and his research team have described this fascinating Triassic reptile, which boasted a distinctive crest of appendages measuring up to 15.3 centimeters, 6 inches in length, along its back. Named Mirasaura Grauvogeli, this peculiar species, despite having a skull that superficially resembles that of a bird, is classified within a group of diapsids known as Drepanosauromorpha. The anatomy of Mirasaura Grauvogeli reveals intriguing details. Image credit, Spikeman, et al., doi, 1038/S41586-025-099. In the 1930s, 2 well-preserved skeletons and 80 specimens featuring isolated appendages and preserved soft tissues of Mirasaura Grauvogeli were discovered in northeastern France. However, these specimens remained unidentified until recent years when further preparation allowed researchers to connect the crests with the skeletal remains. The paleontologists noted, the tissues preserved within the appendages contain melanosomes, pigment-producing cells typically found in skin, hair, and feathers, that are more akin to those seen in feathers than in reptilian skin or mammalian hair. However, they do not exhibit the typical branching patterns characteristic of feathers. These findings imply that such complex appendages may have evolved among reptiles long before the emergence of birds and their closest relatives, potentially reshaping our understanding of the origins of feathers and hair. Interestingly, the researchers ruled out the possibility that the appendages served functions related to flight or camouflage. Instead, they proposed that these structures may have played a role in visual communication, possibly for signaling or deterring predators. The team's research paper, published today in the journal Nature, opens up new avenues for exploration in the field of paleontology. Read more. https://www.ssw/SWS predatory access. www.nature.com. Articles S41586-025-09167. SNF Speakman et al. Triassic diapsid shows early diversification of skin appendages in reptiles. Nature. Published online July 23, 2025, doi 10.038/S41586-025-09167. But, here's where it gets controversial. Could this discovery redefine our understanding of the evolutionary timeline of feathers? What implications does this have for how we view the development of complex traits in reptiles? We invite you to share your thoughts and engage in the discussion.